Hello all. I'll be presenting my paper, Multimodal Architecture, Applications of Language in a Machine Learning Aided Design Process. I'm currently a research associate at the Harvard Graduate School of Design, and I'll be presenting some of the research developed as part of my graduate thesis in 2022. Recent advances in natural language processing and diffusion models are leading to significant change in the way architecture is conceived. Presented here are three methodologies of generation of meaningful 2D and 3D design, merging text-to-image diffusion models, Stable Diffusion, and DALL-E with computational methods. These allow designers to intuitively navigate through multimodal feedback loops of information originating from language and aided by artificial intelligence tools. This paper contributes to our understanding of machine-augmented design processes and the importance of intuitive user interfaces in enabling new dialogues between humans and machines. That's really through the creation of, at the end, I'll be describing a prototype of an accessible user interface, that this exchange of information can empower designers, build trust in these tools, and also increase control over the design process. I'll begin by introducing the project background and then moving on to describing three machine learning aided design methods. And by the end, I'll be describing this prototype of a user interface with concluding remarks. From writing, drawing, model making to building, language is ultimately at the center of a multimodal process. Architects navigate non-linearly between each of these modes across the creative process. The convergence of text and image processing permits this multimodal process to increasingly be replicated or aided by machine learning models, giving new meaning to language within the creative process. With the development of new natural language and diffusion models, what therefore emerges is the relationship between architecture and language. How will this change existing workflows and methods relating to 3D form generation in early design stages is a question I'm interested in asking. Deep learning models are now capable of generating an infinite variety of high-quality images from natural language descriptions and shorter inferences times from text prompts. The increase in image quality and resolution is bringing forward a new phase of 3D synthesis that will widely affect the architectural engineering and construction industry. Approaches and output resolutions of 3D models vary between generative design models, depth map reconstructions of two images with models such as MIDAS, and state-of-the-art models that use pre-trained text-to-image diffusion models to perform text-to-3D synthesis, as an example, neural radiance field or dream fusion. Each of these processes brings forward new opportunities in collaborative human-machine interactions while fundamentally changing or challenging our agency within emerging creative practices. Two principal models were used within this paper, including Stable Diffusion, a latent diffusion model that uses OpenClip, and OpenAI's DALL-E 2. It's a closed source model that uses clip embeddings and run these through a diffusion encoder with the 3.5 billion parameter glide model. While Stable Diffusion was implemented locally on a Windows laptop, DALL-E was used through a beta image generation API within the visual programming interface, Grasshopper and Rhinoceros. The paper investigates the role of language in this process of multimodal 3D form generation using text-to-image and image-to-3D processes applied to architectural competitions, in this case, one that occurred for the Maxi Museum in Rome, Italy. This paper proposes three hybrid machine learning aided methodologies to impact our architects' evolving agency and creative possibilities. These range from methodologies with inputs that are text-based, text plus image-based, and hybrid workflows, which can navigate non-linearly through a feedback loop. The first of these methodologies positions text inputs and 3D outputs within an intuitive or manual approach. First, the text is created by the designer as a simplified or abstracted description of the design brief, and then through a series of architectural synthetic images that are generated, the user then selects what images to use through these trained non-architectural datasets. Following an iterative process of image generation and curation, the resultant geometry is finally assembled, in this case, a series of exterior facades, leading to a feedback loop across each step. While this concedes the 2D image generation process to these machine learning models through the limited semantic representation of form, this process of interpretation and rebuilding of these images is intentional and manual. In the second methodology, a 3D massing model is first reconstructed and then used to condition the text-to-image processes in this first methodology. Environmental, site-specific, and project-specific elements from the brief are translated into 3D form. For example, the massing areas, the building code, site constraints, and program distribution. Here you can see the massing that reflects the 2022 open call competition of the Building Research Center adjacent to Maxi Museum by CAADRIA architects. With the use of these inputs, both machine learning models were used to test out several exterior and interior views from entrances and glazed facades to circulation spaces and research labs. These were then used as inputs together with text prompts and permitted greater control in generating images based on specific elements of the building to then be reassembled with greater control in 3 dimensions. The third methodology uses 2D feature extraction through depth map models such as MIDAS in a process of assembly that combines plans as a spatial logic with exterior and interior 3D spaces to create a concept design. Here, the first two methodologies are hybridized with the massing logic sketched at first by hand to constrain this overall massing volume and used as an input image to generate a plan logic. This is then combined with exterior images generated by prompts such as a research building by Carlos Carpa and Zaha Hadid, so the style in concrete with a grand entrance, so materiality in the program. And interior images depicting sequence of open voids, research spaces, and classrooms. What emerges was a process of assembly where depth map reconstructions of textured 2D images were combined with a new internal diagram of the building, establishing new spatial logics. A prototype for a user interface was developed for designers to improve the navigation across methods and gain greater agency within the process. Hosted in Grasshopper, this permits the use of DALL-E 2 image generation API through a custom component. This includes 3 functionalities: creating images from text prompts, creating variations of images of these massing models from the 3D modeling environment, and loading MIDAS depth maps as an output image for 3D reconstruction. At each step, images and 3D models can then be manipulated in Rhinoceros, accelerating the design process and improving the feedback loop of information for modes. Custom components to call this DALL-E API were created using the component called GHC Python by Rahman in 2017 with locally hosted libraries with Python 3.9. Whether through manual image reconstruction or computational workflows, the proposed methodologies rely on a strict process of curation and interpretation. While the research was completed with earlier text-based diffusion models, we're increasingly entering into an early phase of 3D form generation, where lower quality outputs imply increased design or agency. These intuitive processes establish a new dialogue with the support of a user interface and depth map reconstructions, underlying these opportunities both for interpretation and curation of these new processes. To conclude, while sentiment around these tools has disseminated certain fears around the displacement of the architect, this paper demonstrates how creative possibilities in chaining or merging traditional multimodal practices within text to image and image to 3D machine learning models are broad, opening up new creative spaces for hybrid methodologies. As 2D and 3D clip-guided diffusion models develop together with new foundational approaches, it is becoming evident that our agency will shift increasingly towards roles as curators of trained data sets, language inputs, and images, or 3D outputs, or most importantly, of the chosen multimodal process, connecting both intuition and AI tools. I'd like to thank Andrew Witt and Jose Luis Garcia del Castillo Lopez as my advisors during the development of this during my graduate studies at the Harvard Graduate School of Design. I'd additionally like to thank Tatiana Crossley and Ana Gabriela Loaiza for their support. Thank you all for listening.